You can see that we are getting the raw data readings on COM port, and if there is any movement or any change in position, we can see there are changes in accelerometer raw data and gyro raw data. Now let's generate the code. First of all, open CubeMX. Select this one. Click on OK. So after that, it will open the project configuration. Select for part number STM32 F411CE-U6. This is the part number used in STM32 Black Pill. Double click on this one. So here in the connectivity, we will configure SPI1. SPI1 will be used to read the data from IMU. Select the full duplex master mode. Now change the prescaler to 4 because here it is reaching to 8.0 Mbps, but this IMU supports maximum of 7 megahertz. So let me change it to 4. So here it is in the safer zone, and here no change is required. Let the NSS signal type be software. So as we are using a chip select pin as the PA4, select the PA4 and make the GPIO as output. Along with that, whatever data we are getting from IMU, we need to display that to that UART. So I am just selecting UART port 1 here. Let the mode be asynchronous and baud rate be by default only. Along with that, we need to configure the PC13, that is onboard LED, and that we will use just to check if that it is communicating with that IMU or not. So we will blink that LED. So that is why configure it as output. Then generate code. Give a name, IMU demo. Read raw data. We change the tool chain to STM32 Cube IDE. No other changes are required. Click on generate code. Click on open project. Launch. If everything is fine, then this code should get compiled successfully. Let me build project. So it is compiling. Now we will be adding some IMU related functions. Go here, new, add header file, give a name to the header file. So we will give this name. And click on finish. After that, we will copy paste this header file content. Now we will go to the source folder. Again, right click here, then new, file, source file. Give the name as ICM underscore 20948.c. Click on finish. Now copy paste this content. Save it. Now we'll open main.c. Then in the main.c, copy this part and put it inside the main function. Okay. Along with that, include the header file. Save it. So it should get compiled if there are no errors. So it got compiled successfully. Now we have already connected the ST link. So let me do debug now. Click on OK. Click on switch. Click on resume. I can see that onboard LED has started blinking, but I will put a breakpoint here. Add breakpoint. Yeah, it came here, and we can see that some data is also coming here. So that means our code is working fine, and IMU is responding with that accelerometer and gyroscope raw data. Thank you. So in the previous section, we had generated the code. Now I will show the code in running, and we will put a breakpoint just to see the raw values, and we will display the data on the console. So first of all, just terminate it, then start the code in debug mode. So here it is waiting for connection, and we can see that the code has been downloaded and verified successfully. Switch here. Then click on resume. As soon as I will click on resume, the code, the onboard LED should start blinking. So Yeah, it is. Now let's see if the code is reaching at correct place. So here we had already added a breakpoint. Just I will enable the breakpoint. You can see that some row values are coming for gyro. Similarly, for accelerometer also, we can see the row data is coming here. Now we will open the serial port, open the Terra terminal, click on serial, let the port be COM port 4, click on OK, change the baud rate to 115200, new settings. So as of now, nothing is coming because currently the code is at breakpoint. But before that, let's understand how we have connected this USB to TTL converter to that STM32 Black Pill. So its UART TX and UART RX pins are connected to the PA9 and PA10. Now let me resume the code. Okay, we have to remove the breakpoint first, disable the breakpoint, then resume the code. So here we can see that we are getting the accelerometer and gyroscope data. So if I am changing its position, then these values should get changed. Yeah, these are getting changed if I'm just displacing it and on board LED is blinking. Yeah, that's it in this section. In the next section, we will convert these row values to human readable values. Thank you.